Hello, Year 12. So today's lesson is about roots of unity. I think it's 405 from the textbook. Now, roots is obviously the solutions. So solutions of unity, solutions of Z, and that's form of the roots of unity. It's a Z to the power of n equals 1. That's what it's called, unity. Unity is 1. Okay, now we're going to solve this by factorizing it. Okay, so let's do the examples first so that we can have a bit more clear understanding of this. So I'm going to do example here. Show that a cubed minus b cubed equals a minus b, a plus ab plus b squared. Now that is what we call difference of two cubes, just like similar to difference of two squares, but instead of squares we've got cubes there, so we need to prove that. So when he says show that something, it's most likely left hand side equals right hand side. Okay, so I'm going to start with right hand side. Okay, so what I've got on the right hand side is a minus b, a plus ab plus b squared. Okay, so I'm going to expand this one. I will get a cubed plus a square b plus ab squared minus a square b minus ab squared minus b cubed. And I'm going to cancel some of them out. Like that, and I'm left with very simple a cubed minus b cubed, which is same as left hand side. Therefore right hand side equals left hand side as required. Okay, done. Now part B says use the above identity to find the roots of. So we got to do first find the roots of z cubed equals 1, and then show them on an Argand diagram. So second thing we have to do is show the roots on an Argand diagram. Okay, so that's what you have to do. So what I'm going to do is I'm going to do the first one. Okay, so first one I'm going to do is find the roots of z cubed equals 1. I'm going to make this one as equation with a 0 on the side. And that's what's this one? That's the difference of two cubes, isn't it? So we can use the previous equation there. So it'll be z minus 1, z squared plus z plus 1 equals 0. Okay, and therefore z equals 1, or z plus 1 equals 0. We can't really factorize this, so we have to use quadratic formula here because it's a quadratic equation. So I'm going to continue on this one. This one I'm going to go z equals plus minus 1 square is 1 minus 4 times a times c all over 2a is 1. So what I've got left here is this. Now what does that really mean? Okay, so I forgot about that. because let's have a look at here. What do we got here? It's minus 3, isn't it? So that's minus 1 times, so root minus 1 times root 3. So that is I times root 3. We can tidy it up as root 3i. Yep, that's better. So make sure you get that from here to here. Okay, so we got 3 roots here. Now to put it onto Argand diagram, we need to put these in polar form. You know, polar form as a cos and sine, you know. So let's see if we can do that. So I'm gonna put these into two things. One was 2 plus root 3 2i, and then minus 1 over 2 minus root 3 over 2i. So we got 2 roots there, okay, 1 each. Now, how am I going to transform this one into polar form? Okay, so that, I think, R we can do minus half square plus, they both got the same R. What's that going to be? 1 over 4 plus 3 over 4, which is root 1 equals 1. So that's my R. It's not a big deal. Now, theta, the argument. So that's my modulus. My argument is, do you remember the formula? So I'm just going to write it here. Because B over A. And then theta will be inverse tan B over A. But anyway, so we'll get that tan theta equals, for this one, we could put B over A, which will be root 3 over 2 all over minus 1 over 2. We end up with negative root 3. Okay, so tan theta equals negative root 3. So theta will be negative pi over 3, because that's a 60, isn't it? But it's a negative, so it's a pi over 3 is actually 60. Now, if I sketch these onto here, okay, so that's 0, 90, and negative 90, 180, minus 180. So if we go this way, it's minus 180. If we go this way, it's plus 180. Now, with this, we've got minus pi over, okay, so, but what happens here, we have to remember this one is a z equals minus half plus root 3 over 2i. Now, where is this quadrant, guys? This one is what? Negative and positive. So this will be second quadrant, isn't it? When x equals negative, y equals positive, it's second quadrant. And what's this one? This one's negative and negative. So negative x values, negative y values, it's in the third quadrant. And this meant to be in the second quadrant, but here is the fourth. So what I'm going to do is this. I'm going to make it this, like that. Okay, so from here and here is my other one. So that is positive 2 pi over 3. So I can change this one to 2 pi over 3. Okay, so remember that this is important what you do here. So be careful next time. And so my theta is 2 pi over 3 for this root. Now I'm going to work on this root in a minute. So I'm going to change this a little bit. Okay, so let's have a look at this one. So I'm going to work on this one now. And we know that modulus of this will be same as this, because if you square them, it'll be the same. 1/4 plus 3/4, which is 1. Okay, now only thing a little bit different will be the argument. So again, b over a, so I'll go root 3 over 2 all over minus 1 over 2. I will just get root 3, which is just pi over 3. Now I'm going to put this into unit circle. That's this one. That's the pi over 3. Okay. But again, I'm going to push this one up. Now these ones, hang on a minute, I'm going to see that. This one was supposed to be third quadrant, but I'm in the first quadrant. So what I'm going to do is I'm going to make this here. And that goes from here to here, has supposed to be 180. So that part is minus 2 pi over 3. Okay, so therefore it's minus 2 pi over 3. So let's tidy it up. I'm going to push this one up. So what happens now is we got modulus as 1, and then we have a argument as a plus minus 2 pi over 3. And I'm going to put this into a polar form. So first we had a z equals 1. That was previously done. And now next one, 1 is modulus, and I'm going to have cos 2 pi over 3 plus I sine 2 pi over 3 when argument was that. And another one will be z equals cos minus 2 pi over 3 plus I sine minus 2 pi over 3. Okay, so that's what happens. Now I'm going to sketch this. I'm going to sketch this one. So I found the roots for z. Okay, so I've got 3 roots. 1, 2, 3. So maybe we'll put 1, 2, 3. Okay, 3 roots. Now I need to show these 3 roots onto our Argand diagram. So I'm going to push this one up a bit. Okay, so let's have a look. So I'm going to sketch very roughly here, but hopefully you guys use ruler and pencil and properly done. Okay, so that's a 0 here. Now first one was a z1 equals 1, and that's going to be in here 1, because there's no imaginary number here, so it's just the real part that's going to be here. And the z2, it's going to be 2 pi over 3. Now that's not quite 180, because to be pi it'll be 3 pi over 3, but it's less than 3 pi over 3, so it's in a second quadrant. So I'm going to sketch that. That's my z2, and I could say that's from here to here. It would be 2 pi over 3. Okay, now what am I going to do for the third root? I'm going to use different color, and I'm going to go this way, and that's from here to here, minus 2 pi over 3. Now all these modulars are same, 1, 1, 1, and I've got, that's my Z1, Z2, Z3. Okay, so I've got all these roots on the Argand diagram, and if I sort of close it, hang on a minute, I'm just going to go from here to here, also 2 pi over 3. Okay, so I've got everything is going around 2 pi over 3, and if I join the line, I'll get nice triangle up here, so like that. Again, I've done it very roughly, but you can do much better than what I've just done, like that. Okay, so that's my plotting those roots on an Argand diagram. We have this, so that's the real part, that's the imaginary part. Okay.